Hello, my dear friends. Today, in my present class, I will discuss you the basic strength of amines in gaseous phase as well as in aqueous phase. Okay. So before starting my class, I must request all of my dear students to please subscribe my channel to get notified the various chemistry classes which will certainly help you to crack some typical questions asked in your board exams as well as in different competitive exam related to chemistry, especially after class 2. Okay, so without wasting time, move forward. So my present class is basic strength of the amines. Basic strength of the amines. So, my dear friends, at first we'll discuss the basic strength of amine in gaseous phase. Gaseous phase. So, in gaseous phase, the amines are basically three types. This is the functional group of NH2 amines. If it is connected to one alkyl group, this is called 1-degree amine or primary amine. Okay. And here a lone pair exists on the nitrogen atom. And if the nitrogen atom is attached to two alkyl group R1 and R2, these two alkyl group may be same or may not be same. It is not our topic in each, because nitrogen has the valency of 3, so is two valencies of nitrogen is fulfilled by the two hydrogens and rest is fulfilled by the alkyl group. And here among the three valencies of nitrogen, two valencies are fulfilled by the two alkyl groups and rest is fulfilled by the hydrogen atom. Okay, so this is 2-degree or secondary amine. So we have discussed the basic strength of amines in gaseous phase, mind it, in gaseous phase. And the third type of amine is 3-degree or tertiary amine. 3-degree or tertiary amine. Okay. So look, the NH2 in the amine NH2 group, there exists a lone pair, and here it is also a lone pair, and here also the lone pair. And amine can easily donate this lone pair of electron. Amine can easily donate this lone pair of electron to any electron deficient group, like this. So this is the electrophile, and this called the species here it is amine. The species which can donate its lone pair of electron is called Lewis base. So you see it acts as Lewis base. All the amines act as Lewis base. Okay. So all the amines act as Lewis base because they can because the lone pair nitrogen, amine nitrogen atom can be shared, donated to any other electrophile. So as the lone pair of the electron on the nitrogen atom can be donated to any other of the electrophile, the amines can act as the Lewis base. Okay. So again, I request all of my students to please subscribe my channel, and if you have any query, drop this query in comment box so that I can get your questions and queries, and I will be able to answer all of your queries and comments and questions. Okay, my dear friends, and please bring the notebook and try to write all these things, all these notes I am writing on the whiteboard. Otherwise, you will forget all this topic. Okay, so look, the basic strength of the amines. The basic strength of the amines actually depends. The basic strength of the amine, I repeat, the basic strength of the amine actually depends the the feasibility of donating the electron pair. More the easiest way the electron pair is donated, more the basicity of the amines. Okay, so I must write more the feasibility of donating the electron pair, more will be the basicity of amines. More will be the basicity of amines. Okay. So the first degree amine, one degree amine, the amine is attached to one alkyl group, and every alkyl group, as we know, every alkyl group has the plus I inductive effect. Plus I inductive effect, that means electron pushing inductive effect. That means the covalent bond, the sigma bond between the alkyl group and the nitrogen atom, the sigma type covalent bond between the alkyl group and nitrogen atom consists of the two electrons. And the electron cloud, the electron cloud actually, the electron cloud is pushed, the electron cloud is pushed towards the nitrogen atom by the alkyl group. So electron density on this nitrogen atom is enhanced due to the electron pushing effect, plus I effect, positive interactive effect of the alkyl group. So its basicity must be increased, but in 2 degree amine, there are two alkyl groups. So electron pushing inductive effect is much more than the primary amine. And in 3 degree amine, the nitrogen atom is attached to 3 alkyl group. So here the electron pushing inductive effect, that means positive inductive effect, is the highest. Okay, so I must write the alkyl group alkyl group or groups. Here one alkyl is present, so this is alkyl group, and 2 degree and 3 degree amine. There are 2 and 3 alkyl groups are present with the nitrogen atom respectively. So these are alkyl groups plural. So the alkyl groups attached with the nitrogen atom by their plus I effect increases electron density on the nitrogen atom, which in turn enhances its Lewis basicity. Okay, so parallelly as the number of alkyl groups runs as 3 degree amines greater than 2 degree amines greater than 1 degree amines. So more the alkyl group, more will be the basicity. More the alkyl group, higher is the inductive effect, and more will be the electron donating tendency. More will be the electron donating tendency, or more will be the Lewis basicity. Number of answers are this. So the order of basic strength, the decreasing order of basic strength in amines, basic strength of amines in gaseous phase degree amine similarly greater than 2 degree amine greater than 1 degree amine. Okay, so this is the basic strength, the order of basic strength of amine in gaseous phase. But the scenario will be little bit different in aqueous phase. If we consider the basic strength of amines, that means basic strength of primary amine, secondary amine, and tertiary amine in aqueous phase, then the whole scenario will be little bit different. Okay, my dear friends. So we will look for the basic strength of the amines in aqueous phase. The scenario will be little bit different. Okay. So aqueous phase. So in aqueous phase, all the amines, let us start from primary amines. In aqueous phase, all the amines reacts with the water molecule. All the amines react with the water molecule. So it will give okay. So this is the base and this is the conjugate acid. Conjugate acid. So as the strength of this conjugate acid, as the strength of the conjugate acid increases, we all know the strength of the base also increases. The strength of the base in aqueous phase depends on the stability of its conjugate acid. So, as we consider the basic strength of amines in aqueous phase, we must take into account the stability of its conjugate acid. Okay. So, in aqueous phase, as the stability of the conjugate acid increases, the basic strength of the base also increases. Okay. So how the stability of the conjugate acid can be explained? How can we how we can explain the stability of the conjugate acid, such type of conjugate acid, and the stability of such type of conjugate acid of amines can be explained by the hydrogen bonding. How? So for primary, we are taking the consideration of the primary amines. So like this is the conjugate acid, the ammonium ion. This is the ammonium ion, the conjugate acid of primary amine. So these three hydrogen atoms are bonded with the three water molecule by means of hydrogen bonding. By means of hydrogen bonding. So for this is 1 degree amine, and so there are three hydrogen bonding, and for 2 degree amine, number of hydrogen bonding is 2 hydrogen bonding, and for 3 degree amines only one hydrogen bond exists. Okay. So the stability of the conjugate acid acids depend on the number of hydrogen bonding, as the number of hydrogen bonding increases, the stability also increases. Okay, so my dear friends, there are two opposite effects. There are two opposite effects prevail. There are two opposite effects prevail. So one is the inductive effect. The inductive effect, electron pushing effect. So number of inductive effect is highest, but number of hydrogen bond is lowest. So quasi effect and the number of hydrogen bonding runs opposite to each other. So when we are considering the basic strength of amines in aqueous phase, we must take into account the number of hydrogen bond as well as the inductive effect of the alkyl groups. Okay, so these two opposite effect makes little bit different the basicity order of the amines compared to their gaseous phase. Okay, so we must write in aqueous phase the plaza effect and the hydrogen bond effect run opposite to each other. Considering these two opposite effect, the basic strength or basicity order of amines in aqueous phase will be 2-degree amine. 2-degree amine is the most basic amines. 2-degree amines is the most basic amines in aqueous phase, considering the two opposite effect, plaza effect of the alkyl group and the number of hydrogen bonds. 2-degree amines, then 1-degree amine, then 3-degree amine. Okay, so my dear friends, today we should stop here, and in my next class I will come with more important topics and with another such content and important topics of chemistry. Okay, till then, goodbye. And again, I must request all of my students to please subscribe my channel and put your queries and questions in the comment box section. Okay, till then, goodbye.